Let's graph the curve whose parametric equations are given as x equals 2e power t and y equals 1 plus e raised to the power of t, where t is defined as greater than or equal to 0. So to graph the curve, we need some values for x and y. So here I have created the t chart for some values of t. So we will fill this table, and using the values of xy coordinates, we can graph the curve. So let's start to fill this table. When t equals 0, we have to replace into the x as well as the y equation. I get x equals 2 times of e raised to the power of 0. And this equals e raised to the power of 0 is 1. So 2 times of 1 equal to 2. So therefore, when t equal to 0, x equal to 2. And now let's find out the corresponding y. Y equals, we have to use this second equation, that is 1 plus e raised to the power of 0. E raised to the power of 0 is 1. So therefore, this becomes 1 plus 1 equals 2. So we have filled the table when t equal to 0. And in the same way, we can fill the rest of the values. Let's fill for one more value, that is when t equal to 1, x equals 2 times of e raised to the power of 1. So this is approximately equivalent to 5.44. We plug the value of e into the calculator and multiply with 2 so that we get this value. And let's find the corresponding y. So y equals 1 plus e raised to the power of 1. So this is 1 plus e. We can plug the value of e into the calculator and add 1 to it. And when we do that, we get the value as 3.72. So we found the value of x and y for t equal to 1. So this is 5.44 comma 3.72. So likewise, we can find the rest of the points for x and y when t equals 2, 3, and 4. So here I have filled the table for the remaining values of t, that is 2, 3, and 4. So we got these points. We plot these points on a graph and connect it to a line. So let me do that. Okay, so here I'm showing up the graph where I have plotted the points as well as I have connected them through a straight line. So it looks like when t equal to 0, this is the starting point, that is 2 comma 2. And when t equal to 1, the next point is 5.44 comma 3.72. And t equal to 2, this is the point. T equal to 3, this is the point. And t equal to 4, the point is 109.2 comma 55.61. So basically the orientation is towards like that, that is it goes up. And so when we connect the points using a line, we get a straight line. So therefore, we can say that the equation of the parametric or the graph of the parametric curve is a straight line. So we have graphed the curve whose parametric equations is given. Now let's find the rectangular equation of each curve. So for that, I'm going to copy the equation, that is x equals 2e power t and y equals 1 plus e raised to the power of t. So we have to find the rectangular equation of this curve. So for this, we have to solve for x and y, or we have to remove the e power t. We have to basically eliminate e power t from both equation. So using this equation, I'm going to rewrite this as if I subtract 1 from both sides, I get y minus 1 equals e raised to the power of t. So here I have solved for e power t, which means I can substitute into this equation in place of e power t. So therefore, the first equation becomes x equals 2 times of, I replace e power t as y minus 1. So this becomes x equals 2 times of y minus 1. So let's simplify this and put it in the regular form. So this equals x equals 2y. When we distribute the 2, we get a 2y minus of 2. Now I keep it y on the on side, so therefore, this becomes 2y equals x plus 2. We add 2 to both sides. So we get 2y equals x plus 2. When we divide both sides by 2, we get y equal. That is, we have to divide each term by 2. Therefore, this becomes half x. plus 2 by 2 is 1. So basically this is the rectangular equation of the parametric curve.